Okay, in this screen recording, we'd just like to talk about one of the fundamental properties in physics. You've probably heard this word before, but the word is the force. If you're a Star Wars fan, may the force be with you. What exactly does that mean? Let's give force a definition. A force in physics is simply defined as a push or a pull. Some examples that maybe you've heard of in real life, since you live on Earth, probably a real common example of a force that you encounter every day is gravity. Another force which keeps life on Earth pretty stable is called friction. And if you've ever encountered a spring or a rubber band, another force is tension. There are many more, but we won't have time to list them all here. The fundamental idea with forces is that an object will keep on doing what it's doing unless a force acts on it. Maybe you've heard it put that an object at rest will stay at rest, or an object in motion will stay in motion unless acted on by an outside force. In a practical example, a rock sitting on a cliff will continue to sit on that cliff and not move anywhere unless another force acts upon it and causes it to change its motion. Or if you took a cat and put it in the depths of outer space where there's no gravity and you gave it a velocity and it was flying through outer space, it would continue on flying through outer space unless some other force acted upon it. Another idea in yellow is that forces are vector quantities. Maybe this is a new word to some of you. A vector is a measurement that has two things applied to it. A vector has both a magnitude maybe you could think of that as it has a size value to it. It has a quantity, so it has a magnitude and a direction. So when we talk forces, they are vector quantities, so you have to say the force was acting with this value and it was acting in this direction. Let me give you a quick example of that. Forces in your textbook and in most physics books are drawn as arrows. So if I just try to draw an arrow here, and then I break up that arrow, the size of the arrow matters. In this example, maybe this arrow represents a force that can be described this way: 60, and I'm just going to use the symbol N. N stands for newtons. Later on we'll learn about that. That's the quantity that forces are measured in, 60 newtons. And since my arrow is pointing to the right, I could maybe describe it as the force was acting 60 newtons east. And so if this line represents 60 newtons east, this little segment might represent 20 newtons. This could represent 20 newtons. 20 newtons. And so its size or magnitude is 60 newtons, and it's pointing to the right, which would be east. Let me draw another arrow. And have you guess what would be the value of this force. How could you describe it? I would describe this as 40 newtons west. Usually in physical situations, more than one force is acting on an object. And so to figure out the total force that's acting on an object, you just simply add them together. So if we complete this statement, forces can be added together to come up with what is called a net force. Let's just have a couple examples. Draw a little diagram here. Forces. What is the result, or what is the net force produced? Let's do two. If I have a block that has 10 newtons of force acting to the right, and also on that same block there is 5 newtons of force acting to the right. So what is the total of those forces? Well, you have to total up their directions, and you have to also total up their magnitudes. So the net force acting on this brick would be, if you sum those together, 15 newtons to the right. Another example, another block. In this example, we still have 10 newtons to the right. But the second force is 5 newtons to the left. Notice they are in opposite directions. So if you were to add them together, sum them, the sum would be 5 newtons to the right. You have more force acting to the right than you do to the left. And so 5 of the 10 newtons is subtracted and you're left with 5 newtons. And one more example. Another brick. 5 newtons to the right. 5 newtons to the left. The overall net force on that brick would be 0 newtons. You could describe it as the net force is 0 newtons acting on that brick. If the net force is 0, whatever the brick is doing, whether it's moving or whether it's still, it will continue doing what it's doing because there is not a net force acting on it. And let's draw one more quick picture. Say I have a brick suspended, or it's being pulled down by Earth's gravity. Gravity is a force. And say it's being pulled down with a value of 10 newtons. In our everyday language, we could call that its weight. As Americans, we're used to pounds, but in physics, we'll get used to newtons. Well, if I take that brick and I suspend it from a ceiling, and it just sits there and doesn't move, that must mean its net force is 0. 10 newtons of weight pulling down, and then 10 newtons of some other force pulling up. And that other force we could describe as tension. And again, we could quote its value as 10 newtons up versus its weight, which is 10 newtons down. Those will cancel out and give it a net force of 0. And if the net force is 0, it's going to keep on doing what it's doing. So if it's hanging from a ceiling and not moving, it will continue hanging from a ceiling and not moving. I think we'll add more to this in later lectures, but for now, I think that's a good start for the idea and the concept of force. We'll talk again later.